Hey Pixels, one of my favorite things about this new ecosystem that Kubernetes helped create is the whole methodology of GitOps. And what GitOps is, well, let me show you. So with traditional CI/CD pipelines, you would write your infrastructure code like normal, right? And then you trigger some sort of CI/CD pipeline which would deploy your changes, like running a script in order to deploy your changes into your production environment. Now, the problem with this is most of the time when we would run the commands to deploy, you're doing some sort of mutation which doesn't necessarily exist in your source code. So, for example, let's say you want to deploy a new version of an application, you end up patching a resource or you end up saying, hey, run this configuration with this different image tag. And the problem with that is in production, you will end up with a deployment which does not represent what you have in your code exactly. So there's a disconnect that happens. There's a complete disconnect between your production environment and your source code. And this is how we always did deployments, right? The problem with this is fundamentally it makes it a lot harder when you're reading the source code to know exactly what is in production. Fundamentally, I believe that your source code and your production environment should completely match. It should be so transparent when you're reading one to know what's happening in the other. Likewise, you should be able to go to your cloud environment, read the configurations, and know exactly what to look for in the source code, because there will be a one-to-one mapping between code and reality. Now, a lot of people claim GitOps for various tools that exist, and to some people, they think GitOps just means storing configurations or code in Git. It isn't. The reason why GitOps evolved with Kubernetes is because the configuration file is literally the configuration Kubernetes uses internally inside of its etcd database in order to understand the state of the cluster. And Kubernetes will constantly try to reconcile with the configuration in the etcd cluster to ensure whatever is there is a reality, right? So it's constantly trying to reconcile itself. And this is one of the beautiful things about the operator pattern, because you can write your own code to do this reconciliation for your own types of manifests. Now, this video isn't really about how Kubernetes works internally, but it's important to understand that Kubernetes helps facilitate the GitOps methodology. Now, we're not actually replacing our etcd database, but practically we are. Because what we're doing is we're going to store the desired state for our code base inside of our Git repository. And then we'll have our reconciler in the middle, which is going to be Argo CD for the purpose of this video, sits in the middle, ensuring that the intended state, which is what's inside of the etcd database, matches with our desired state. This also means that if something happens to our intended state which causes drift, that the desired state will always be applied back. So what this means is that what's inside of our cluster will always represent what is inside our code base. And that's the beauty of GitOps. So I can look at the code, I can clone the repo, and I can know what is in production. I'm not guessing what's in production. I'm not necessarily having to double check. I can see by looking at the code exactly what is in production. The other great thing is that because you're now using Git fundamentally as an extension of your internal etcd database, you then get all of the power of Git in managing the database. For example, rollbacks become very easy because, well, that's handled by Git. You can just revert to a previous commit. Changes are now managed by Git, so if you want to have permissions or restrictions, you can obviously use pull requests, right? Have protected branches. All of the normal facilities of Git are at your disposal in helping you manage your cluster. Now, there's many different implementations of GitOps. It's a fundamental philosophy which was started at Weaveworks, which unfortunately, as I explained in a previous video, no longer exists as an organization, but their main product still thrives on, which is Flux CD. However, in this video, we're going to talk about Argo CD and how to set it up and get going. And the reason why I use Argo CD is A, it's my favorite, and B, the reason why it's my favorite is you gain this nice user interface to help you manage your cluster. Now, the user interface isn't for me as someone who manages Kubernetes, but the reason for me why I like it so much is it gives your developers the power that they need over their own applications. I often encourage developers to take ownership of their application's Kubernetes manifests so that they're able to change the manifests to fit the needs of their application as they want. However, obviously, because they're not Kubernetes experts, they may do something which breaks their deployment. So the ability for them to be able to see this in a nice GUI makes it very easy for them to be able to debug their applications when they go to release to staging or dev or whatever environment that they go to first. So I have my Kubernetes cluster here. This example is just running in Google Cloud, and I'm going to install Argo CD in it and use Argo CD to manage some deployments so we can see how that works together. Now, Argo CD has some community maintained Helm charts, which we can go to here in Git. We can do Helm repo add, just like it suggests here, to be able to add the repo locally, so it's easy to install this chart. We can then do Helm repo update to be able to get to all the different updates from the different repositories we have installed. And then we can do a simple Helm install command. So what I'm going to do here is Helm install. I'm going to give the installation the name of Argo-CD. I'm going to point to the Helm chart here. I'm going to put everything into the namespace of Argo CD. We're going to create that namespace. I'm going to install this version of the Helm chart, and I'm going to run it with these basic configurations I have here. All I'm doing is I'm just changing the logging to 1, just so we don't get so much logging. And I'm just going through all of the resources. I'm making sure the replicas are set to 1, because otherwise it creates more replicas and I want to keep it as small as possible. And I'm just setting some generous resources and limits. The other thing of note is under server, I'm just setting it in secure because otherwise it will generate a self-signed certificate, and for simplicity, I'll just want to connect to it with HTTP. Then we'll give that a moment to run and we should see it start to create the Argo CD resources inside of Kubernetes. Now, I will admit Argo CD isn't the lightest of GitOps implementations, partly because of that user interface. But we will talk about some good practices in a moment on how to keep it as lightweight as possible. So I can now go to the server pod in K9's, do Shift F and do a port forward. I'm going to forward to 8080 inside of the container, and I'm going to bind it to my local port of 8080. So then I can go to my browser and go to localhost 8080. And this is Argo CD. By default, it creates a login for you. And we can go back to the cluster, go to our secrets, find our secret with K9s, we can press X on it, and we can see that by default, it's created a password for the admin account. So we can log in with admin and that password, and we're inside of K9s. Now, by default, with the Helm chart, Argo CD is set up with all of the permissions it needs to manage your Kubernetes cluster. So let's try and deploy our first application. Now, Bitnami is known for hosting loads of basic Kubernetes Helm charts. So let's see if we can find a Helm chart just for Nginx. So we come here to Artifact Hub, and it basically just acts as a registry just to link you to Helm charts that you can get from various sources. I always recommend you to check out the source code where you can come down here and actually look at the Helm chart. It's always good practice, and I always say this whenever you install a Helm chart, just to have a look what's going on. And that's not necessarily entirely out of a security point of view, but just so you know what you're installing, right? And always have a good look at the values and see what types of things you can override, because the defaults may not always align with what it is you want to do. But first things first, let's get this managed by Argo CD. So if you scroll down, you'll see it will give you the install command like this. And we can go back to Argo CD and press New App, give it the name Nginx, set it to the default project. We'll explain what that means in a moment. Scroll down and you'll see it says repository URL. Usually what this means for a repository URL is whenever you see this command here, Helm repo add, and then you have a URL here, usually it's that URL. So for Argo's Helm charts, this would be the repository URL. For OCI, it is a bit different. OCI is a more modern and efficient way of storing Helm charts, and you should always prefer to use OCI whenever you have the opportunity. So Bitnami used to have their Helm charts hosted on this URL. And the way that it works with a normal Helm repository is you have an index.yaml file which stores a list of all the Helm charts within this Helm repository. The problem is this is after Bitnami has truncated and reduced the size of this file, but only listing the latest versions of repositories. As you can see, this is a huge file. And so anytime you're downloading any chart, you had to download the entirety of this index YAML file. So whenever you have the opportunity, always prefer an OCI image registry. So unfortunately, with Argo CD, you can't just copy this OCI line like this. So what we're going to do is we're going to copy the host name, but we're not going to copy the actual chart name. So we're just going to copy the registry1.docker.io.bitnami charts, but we're not going to copy the nginx part or the OCI://. And if we do that, then Argo CD is able to understand this. So if we change this here to Helm, we'll be able to select the nginx Helm charts like so, and the version we want to install, which is the chart version, not the application version. The chart version is the version of the chart we're installing. The application version is the version of, say, nginx that's being deployed by the chart. Then we can select the cluster URL like this, leave everything as it is. You can see here that it's giving me the option to override values like this, but we're just going to ignore that for a moment, scroll all the way, or we don't need to. At the top, you see it says create like this. So this is a simple way to create your first application in Argo CD. Now, by default, it doesn't actually do anything, and that's because we didn't tell it to sync by default. So we're going to do that manually. We're going to go into the application, we're going to press sync, and we're going to see that everything goes from yellow to green. We're going to see there's some things here in progress if I zoom out a bit. The pod now has a green heart next to it, so that means it's been successfully deployed. I have a complete overview of everything that this Helm chart has deployed, the health status of that particular resource, and everything that it subsequently created. So we can see here very distinctly that a deployment created a replica set, which created our pod, which created a Cilium endpoint in this example here. And if we go to the cluster, we'll see that it's deployed this pod nginx inside of the Argo CD namespace. Now, it's in the Argo CD namespace because we didn't actually tell it to deploy to any different namespace, so it's defaulted to the one Argo CD runs in. And then we can go to edit this configuration, and if you remember before, we saw the different parameters. So right now, we could go to edit, turn on auto-scaling, change the min replicas to 2, the max replicas to 5, save, and we should see this now updated. It's not syncing by default because remember we haven't enabled that yet, but if we press sync manually, we tell it to synchronize, we'll see that it's going to create this HBA, this horizontal pod autoscaler resource. We see that it's in progress. We can go to the cluster, we can have a look. We can see that it's now deployed it, and we can see that it seems to be working. So it should now have a green health bar inside of the cluster here because we can see the HBA is working as expected. It set the min pods to 2, the replicas to 2, and just like that, we have 2 nginx pods running inside of the cluster. So as you can see, this is really powerful to be able to give to developers and tell them, hey, you can now manage your application in the cloud environment. You don't need me as a Kubernetes expert to manage your deployment. Now, let's say I do something completely wrong, like instead of setting the max replicas to 5, I set it to flobby, and I save this. And let's try and sync flobby as my max replicas into the cluster. And we'll see I get a sync failed. So I can go into this, and you tend to find that the way that these error messages work is you always want to read them near the bottom first, because it's giving you the full Helm install command here. But we can see here that max replicas flobby is an unrecognized type because it should be int32. That can still be confusing to some people what resource it's talking about, but if you scroll down, you'll see here that it's specifically talking about this resource here. It has an invalid value. Max replicas flobby would make this an invalid Kubernetes configuration. So like I said, when a developer makes a change, it makes it easy for them to say, oh, I've messed up there, right? So that's great, but I thought we were talking about GitOps, right? I've just shown you the Argo CD interface, but how's any of this GitOps related? So let's delete this. And what you're going to find is it's going to go through all of the resources that it created, and it's going to clean them all up for us. Now, in order to demonstrate this, I'm going to use a tool called Gitea. Basically, you can use this with GitHub, GitLab, any sort of Git provider. Just for simplicity right now, I'm going to use Gitea, which is a self-hosted Git tool. So we'll be able to focus on demonstrating Argo CD without necessarily demonstrating how it integrates with different types of tools. So we have our deployment code here for Gitea. I'm just going to deploy the Gitea image. I'm not even going to save any volumes or anything. So it's just going to be completely temporary information. I've just defined a quick whitelist for the webhooks that we'll use in a moment. It's not really important, but just so you know it's there. and I've created a service for the Gitea instance. So if I apply this into my cluster with kubectl apply -f dot, and we'll apply everything in this folder, we'll get a Gitea instance running in the default namespace, which I can port forward to. And we're going to open that on port 3000 locally. It's going to give me a installation configuration screen. I'm just going to quickly set a admin account, just git. And very quickly, I'm just going to create a repository, and let's call this GitOps. We're going to initialize the repository just so it is already set up with some files in it, and do create repository. Now, what I'm going to do is I'm going to clone this Git repository locally. So username, I made Git, password Git, the URL is localhost, and the repository is GitOps. And before we actually do anything, let's configure our repository. So if we go into the repository like this, we can go to webhooks, we can create a webhook, and I'm going to point it to the Argo CD server inside of Kubernetes. So just to remind you, this is the service you see here, Argo CD server in the namespace of Argo CD. Is HTTP because I remember I set it to insecure. And it's the path API webhook, right? /API/webhook. We're going to HTTP method post, content type application JSON. And for now, we're going to do trigger on push events. You can configure a secret, but we're going to keep it simple for now and just say add webhook. So whenever a change is uploaded into this repository, it's going to send a webhook to Argo CD and tell it that a change has happened. This is to make sure that when Argo CD wants to sync with our repository, that syncing is triggered almost instantly rather than waiting for Argo CD to necessarily poll or whatever. We should be able to also do test delivery and validate that we're able to actually make this connection. And we can see green tick. So now we have this repository here. Let's add some basic configuration to it. So I just went to get some basic configuration file here. This is just going to install an Nginx deployment. So let's create a new file. Let's say deployment.yaml. And obviously I have to go into this to do git add, git commit. Let's give it the name of v, git push. And we now have this deployment.yaml inside of Git. Now you'll notice that nothing actually happens inside of Kubernetes yet, because while Gitea has sent a webhook to Argo CD that this repository has been updated, Argo CD isn't actually watching this repository for an application to be deployed. So let's add that configuration into Argo CD. So we can do new app. Let's call this application GitOps. We're going to give it the default project name. This time we're going to change the sync policy from manual to automatic. And this is what's going to make it automatically sync the changes and not need us to press that button. We can also then tick prune resources, which makes it so if you remove something from Git, then Argo CD will automatically remove that resource to ensure that what's inside your Kubernetes cluster does match what's inside a Git. We can also tick self-heal, which will ensure that if there is a conflict, Argo CD will always enforce the changes that you have made in Git. So ticking both of these, in my opinion, should be the default, and unticking them should be if that application specifically needs that configuration. And just to remind you, there are different sync options here that you should always consider using if they match your specific use case. One good option to always be aware of is this one, server-side apply, because if you've ever tried to commit a huge manifest, so for example, a custom resource definition, they tend to be huge files, you will have to tick server-side apply, because that changes how Kubernetes applies it internally and allows for larger manifest files. It also tends to make things a bit more atomic if you have mutating webhooks. I can point it to the Gitea service I created. It's on port 3000, the GitOps repos, HTTP, that's the username and password here. In this example, it's a Git repo, not a Helm chart. We can set the path, and as you can see here, it's actually on the root of this repository. So I can say / change the cluster URL to be this cluster, and let's change the namespace to default. So it's going to deploy into a different namespace. Then we should be able to do create. Nope. The path has to be dot maybe. Yes, the path has to be dot instead of /. We can see that it's immediately synced it. We can see that it created a deployment, which created a replica set, which created 3 pods, which created a Cilium endpoint for each one. And we can see it all here inside of the cluster. Now you may think, what's the benefit of doing it this way than the previous way? Because I still created it manually inside of Argo CD. But the benefit now is this repo is now monitored and watched by Argo CD. So for example, let's say I change the replicas to 1 and we update it. So we do add, give it a commit name, push it. And as we can see, it's now updated. It tells me the commit that it's updated to. It's not really helpful because I'm giving them all the name V. Now, because we now have this repository managed by Git, we can now, like I said, use the default functionality of Git to manage this application. So for example, let's say we wanted to roll back this repository by 1 commit. We could do a head reset, and then we could do a git push and force it. And we'll see that it now updates inside of Argo CD to match our new configuration, because we have now rolled back that whole repository just using Git. Now, you can also see the other power of this, like I said before, by using Git as your orchestration tool, you can use all of the features that typically come with Git. For example, pull requests. This becomes an audit log. So like I was just doing with Git log, you're seeing a whole audit log of who made what change, what time was the change made. And if people have good descriptions that may be able to trace that change back to a ticket in Jira or Trello or whatever tool you're using, you have this complete audit log of all changes and the source of them, which is quite powerful, really, because if you were to try to do this with a traditional CI/CD solution where you're doing something with, say, kubectl apply, you might end up having to dive into audit logs, find out that these audit logs don't have all of the information you need. Maybe they haven't been properly annotated with the right information. Like, for example, it may just say everything has been deployed with the admin user, and you don't know who actually initialized that specific deployment. But as you can see here with Git, because everyone is tied to a Git account, it makes it very easy to be able to tie that to an employee and understand why they made the change they did, right? So this is why GitOps becomes so powerful, because you start leveraging all of these extra tools to be able to help you manage your Kubernetes cluster. Now, typically in an organization, you're going to have people in different roles or teams, and you'll want those people to have access to different resources or to be managing different resources. For example, it may be that you want your front-end team to be able to manage their front-end in production, but not to be able to manage the back-end API. And alternatively, you might want your back-end team to be able to manage the back-end, and likewise not the front-end. So how do we make that segmentation inside of Argo CD? So a project is, as it says here, a logical grouping of applications. You could think of it as like a namespace, and it allows you to add restrictions on what a project can do. And you can then give people permissions to a project. So by default, if we go to the default app project inside of the cluster and we look at the configuration, we can see that it's giving you permission to everything. So if you have permission to the default app project, you will basically be able to manage the whole cluster. Now, it could be that by default you delete this app project, or alternatively you make it so only an administrator can use it. But what we're going to do right now is we're going to create different app projects for different teams and give those different teams different namespaces in Kubernetes for the applications to live in. So I'm going to create 2 different namespaces. The first one I'm going to call Team A, and the second one I'm going to call Team B. Then I'm going to create 2 projects. One is going to be called Team A and Team B. They're both deployed into the Argo CD namespace, because right now that's where we're managing our applications from. We can change this, but for now, everything is inside of the Argo CD namespace. And we're saying that Team A have the ability to deploy any resource they want. If you wanted to, you could restrict the different resources that they can deploy here. But we're saying that Team A can only deploy into namespace Team A and this current Kubernetes server. We can also restrict which repos we allow them to install to, and you can use a wildcard afterwards. So for example, if you remember, this is our Gatia URL, we could say that Team A is only able to deploy applications which come from our Git server, for example. But for now, I'm going to keep it as a start and just demonstrate that these 2 teams have different namespaces. And then we're going to apply these configurations. And then what we can do is we can create 2 new repos. So I'm going to create a repo for Team A and for Team B. So new repo, let's go team A, initialize it, and go new repo, team B, and initialize it. And I'll clone both of these locally. Okay, so team A has its deployment here, and team B has its deployment here. And very quickly, obviously, we have to add these into Git. Okay, so how do we actually deploy these applications? One way is we could obviously go to Argo CD as we've been doing already, do new app, and create both applications manually like this. But we got to stop creating stuff manually, right? I thought this was meant to be infrastructure as code, right? So we have to create this automatically. Now, if we go over to our GitOps repo, as we have here, we can create an application which installs these applications. And this is what's called as the app of apps methodology. So you have an app which installs other apps. And you can take this as far as you want. You can have an app that installs apps and installs apps. It all depends on how you want to structure the deployment of your repositories. My recommendation, though, is to keep it as shallow as possible, because by doing that, you reduce the complexity of your infrastructure. So what we want is we want to have our GitOps application here deploy Teams A application and Team B's application. So what I've done here is I've created an application as a Kubernetes manifest. I've given it the name of Team A. I've given a finalizer here, which means that if we try to delete this application, it will try to make sure it cleans up any resources before it deletes it. We've given it a destination, which is going to be the namespace Team A, and we've defined the server here. You'll notice here I've set the repository URL, which is my Git repo. I've set the path to dot, just like we did manually when we made the app. I've set the project to Team A, and I've given it the sync policy configuration here. And I've done the same thing here for Team B. So if we apply this, by obviously making the changes in Git, we can see it now deploying my old Nginx deployment and adding these two applications here. And you'll see that if I go out to see all my applications, you can see that these applications now exist in my overview here. And when I'm inside of this application, it gives me this button here to be able to open that application directly. So it's easy to traverse through the app of apps structure. And if we go back to Kubernetes, we'll see that we have two pods down here in each of the respective namespace, Team A and Team B. Now, why did we do that? Now, if you remember for the GitOps application here, we're setting the target namespace to default. But because it's got the project default, I can do whatever I want here. So if you remember when I made these applications, I actually set the namespace to Argo CD. So there's no locking down on this deployment here. It's completely open. I can do whatever I want. However, let's say Team A is feeling sneaky. They've gotten annoyed with Team B, and they're annoyed how Team B is always so slow to do anything, right? So maybe Team A thinks, you know what, I'm going to deploy another thing inside of Team B's namespace, use their secrets, because they're so annoying, and we want to create our own, proxy or whatever, to get around them taking forever to make any changes. So let's say Team A wanted to do this, right? They have full permission to commit whatever they want into their repo. And you can commit it just fine. There's nothing to restrict you from committing this. But when you go to sync these changes, you'll see it says sync failed. And the reason is because the namespace Team B is not permitted in the project Team A. Essentially, Team A don't have permission to deploy into this other team. And so the plan to hijack Team B's namespace is completely foiled. One of the other great things with Argo CD is you can set up RBAC so that, like I mentioned before, if you link this to your SSO, you can restrict users by their roles or whatever to have different types of permissions inside of Argo CD. And that can be as simple as restricting which interfaces they can access, like which pages they can access, or what actions they can do, like do they have permission to sync or do they have permission to view? Can they make applications? Can they delete applications? But also greatly make it so they can only see, here we have example project, in this example here, they can only see their specific project, meaning that if Team A were to have their permissions locked down and they were to log into Argo CD, they not only wouldn't be able to mess with Team B because we split things off into different projects, but they would also only see their applications which exist inside of their project. Now, the great thing here is while we've deployed an application like this, we can also deploy any sort of Helm chart like we did manually at the beginning. So with the same exact resource here, we can create an Nginx resource just like this. So it's basically the same thing here. For source, we have the chart, the name of the chart here. For repo URL, we have it exactly as we did it when we did it manually, especially when it comes to OCI. Make sure you get that right. Target revision, which is what is the chart version that we want to install. And if we push this, we should see inside of our cluster the Nginx Helm chart being deployed like this as an extra application here. And we can see it's a Helm chart, and we can go into it here and see it's currently deploying it. And once again, under GitOps, it's now listed as another app of apps, right? Now, one of the fundamental differences between GitOps and a standard CI/CD pipeline is if we were to update one of our applications here in the standard CI/CD pipeline, we would usually use some sort of replace or apply command in order to change the container version that we want to deploy, right? So we might say, change this deployment to use this version of the image, or apply this version of the manifest which has this version of the image. Something like that, right? Now, that's not a good idea of GitOps, because if we were to run this type of kubectl command, then we would have a mismatch between our Git repository and our live server, which ultimately means that our Git repository would want to overwrite these changes and therefore roll back our release that we just made manually. So this usually means as part of your release process, you will need to not only patch this value inside of the file, but also on top of that, as part of your release process, do a git commit with the relevant changes. And this is how you can always make sure what is in Git is representative of what's in the cluster. Like as part of my CI/CD pipeline for my Apply Pixels repository, you can see that it actually has the changes in the repo for releases of my website. So we can see here, we got an update to my tag, this is Helm, and we've replaced it like so. So this is how you can always make sure, even when you do releases, that your Git repository is a genuine source of truth for what is in your cloud environment. Now, in a future video, I'll actually expand upon how you can create a CI pipeline which integrates smoothly with your GitOps continuous deployment method. And I'll also create other videos on how we can have more advanced deployment methods with Argo CD, for example, Canary deployments with Argo rollouts, or alternatively other topics like, I have this article here on our website, how to handle migration jobs inside of Argo CD. That requires a whole level of extra planning on how to manage your configurations. Now, I hope that's given you some insights on how you can get started with GitOps and deploy and get running with Argo CD inside of your project. If you need any help, please feel free to leave a comment down below or reach out to me directly and I'll do my best to help you. If you need assistance in your organization to set up and maintain GitOps, please feel free to reach out and we'll be excited to help you along on that journey. I hope this video has been really helpful, and as always, I hope you guys have a really lovely day. Thank you so much. Cheers.